Welcome. Now we're going to look at solving a system of equations using the elimination method. And the elimination method is useful when we have um, lots of different terms. So here we've got x squared and y squared and y squared. So notice this is organized. We have our x squared terms, our y squared terms, and our constants. Having them organized is going to be very, very important. So depending on how they're given, you may need to rearrange. In this case, it's obviously presented in an organized fashion. So let's look at what we're dealing with and try to determine how many solutions we think we're going to have. Our first equation, 2x squared plus 5y squared equals 39. This is an ellipse. Specifically, a horizontal ellipse. If I were to divide all of these terms by 39, the larger number would be under the x value. So this top equation is a horizontal ellipse. The bottom equation, well, it's a hyperbola because we have different signs. X squared minus y squared. I'd be inclined to think this is a horizontal transverse axis hyperbola. But what's going to happen when I divide by a -1? Those signs are going to switch and we'll have y squared minus x squared. So this is actually a vertical transverse axis hyperbola. So let's think about what that would look like. I'm going to draw a horizontal ellipse. And essentially, I could maybe have some vertical transverse axis hyperbola, which looks like this. How many possible or maximum solutions is this going to give me? There are 4 points of intersection. We're going to have 4 solutions, or rather 4 ordered pairs. You know, we could have 2 real and 2 complex or imaginary. We could have all real or all imaginary. All right, but there will be 4 answers. So let's look at using our elimination method. When we deal with the elimination method, we look at eliminating one variable. I oftentimes look for a least common multiple or opposite signs. I'm going to choose to eliminate my y variable first. Now, there are infinite correct choices when we're using the elimination method. It's just that you, as the student, you want to choose the path of least resistance. So if I take this bottom equation and I choose to multiply it by +5, what will that give me? Well, let me rewrite my top equation. I've got 2x squared plus 5y squared equals 39. And multiplying the bottom equation by +5 gives me 15x squared minus 5y squared equals -5. Now you notice that these y squared terms have opposite coefficients. What I'll do here is I'll add these 2 equations together now. And adding those 2 equations is going to cause those y terms to cancel. So I end up with 17x squared equals 34. Dividing on both sides by 17, that would give me x squared equals 34 over 17, which is 2. And then using my square root principle, I'll have x equals plus or minus the square root of 2. Now, I only have 2 x values, but we know we're going to have to find 4 possible solutions. All right, well, let's continue working through this. So I have some x values. I have specifically 2 x values, positive root 2 and negative root 2. I'm going to take each of these x values and plug them in to at least one of my original equations, and they should both, if I've done this correctly, it shouldn't matter, they'll both give me the exact same output values for y. So I'm going to choose the bottom one here because it's dealing with slightly smaller numbers. So let's look at x equals positive root 2. we're going to plug that into 3x squared minus y squared equals -1. So that gives me 3 root 2 squared minus y squared is -1, or 3 times 2, 6, minus y squared is -1. Subtracting 6, negative y squared equals -7. Y squared is +7. I have y equals plus or minus the square root of 7. So for this singular x value, I get 2 output y values. That gives me 2 ordered pairs. I have positive root 2, positive root 7, as well as positive root 2, comma, negative root 7. So let's look at x equals negative root 2. So we'll choose the negative of that value and we'll plug it into that same equation. It gives me 3 negative root 2 squared minus y squared equals -1. And running through some very similar algebra, we again get 2 output y values, which correspond to this input negative root 2. So now we have the ordered pair negative root 2, and we would have positive root 7, or negative root 2, comma, negative root 7. And here we have 4 unique different ordered pair solutions. So that's how we use the elimination method to solve a system of equations. In this case specifically, we were finding the 4 points of intersection for the horizontal ellipse and the vertical transverse axis hyperbola. As always, email me, contact me with any comments, questions, concerns, because I am here to help. Ta-ta for now.